Now, in this video, we're going to take up one more problem, the problem number 9. A 25 mm diameter rod subjected to a tensile load of 50 kilonewton. The extension of the rod was found to be 250 divisions in the extensometer of 200 mm gauge length. If each division of the extensometer is equal to 0.001 mm, find the modulus of elasticity. So here, a data given is the diameter of the rod, which is D, which is 25 mm, is subjected to an axial tensile load of 50 kilonewton, which is equal to 50 into 10 to the power 3 Newton or 5 into 10 to the power 4 Newton. Delta, the extension of the rod, is 250 divisions, so the least count of that is 0.001. So 250 into 0.001, which will be equal to 0.25 mm. Because he says 250 division, each division of the extensometer is equal to 0.001. So for 250 into 0.001 will give you 0.25 mm. And then the length of the rod, which will be gauge length, is 200 mm. So what is the Young's modulus of the material, which we need to find out, or the modulus of elasticity? So what is the stress? P by area of cross section, which is P by A. Strain, which is delta by L or delta L by L. Then what is modulus of elasticity, which is sigma by epsilon, which is equal to P by A by delta L by L, which is equal to P into L divided by delta L into A. So here, what is the load? Load is nothing but 5 into 10 to the power of 4. Substitute the value of P as 5 into 10 to the power of 4. And length of the bar, which is L, substitute the value of L as 200 divided by the delta L is nothing but 0.25 into then area, which is the diameter is given, so pi by 4 into 25 square. So therefore, Young's modulus or the modulus of elasticity of the bar or the rod is 81487.3 Newton per mm square. Now we're going to take up one more problem, the problem number 10, which reads as a hollow steel tube is to be used to carry an axial compressive load of 150 kilonewton. The yield stress for steel is 250 Newton per mm square and a factor of safety of 2. The following 3 class of tubes of external diameter 100 mm are available. The class and thickness is given. The light is 3.5 mm thickness. The medium class is found to be 4.0 mm thickness, and heavy class will going to be 5.0 mm. Suggest the suitable section. So what is the permissible stress? Sigma, which is yield stress by factor of safety. So 250 by 2, which will be equal to 125 Newton per mm square. So also what we know, sigma is P by A. So sigma is calculated the value, you substitute the value of 125, which is equal to 150 into 10 to the power of 3 by A, where area of the cross section of the tube A will be equal to 1200 mm square. For hollow section of outer diameter D and the inner diameter small d, which is area of cross section, which will be equal to pi by 4 into capital D square minus small d square. So that is area of cross section is 1200, which is equal to pi by 4 into the outer diameter is given to be 100 square minus d square. On simplification, the inner diameter of the tube D will be equal to 92.044 mm. But we want it in the terms, we know the outer diameter and we know the inner diameter. Therefore, we will be able to get the thickness because we need to suggest what type of thickness we need to select. So for that, T will be equal to thickness of the tube. T will be equal to capital D minus D by 2. So capital D is 100 minus small d, which is the calculated value, which is 92.044. The entire thing is divided by 2. You will going to get it as 3.978 mm. So the T is equal to 3.978 mm. Hence the suggested section is in the range of the medium class. So this is how you will be able to solve this problem. If you find this video is suitable, and please subscribe to my channel. Thank you.